Kelly, can you tell me a little bit about the strategy you used this semester to help your students?
You bet. So what in the math ed faculty, what we were finding is that all of, I shouldn't say all, many of our students are coming to us with a bit of a fixed mindset about what mathematical understanding and achievement means. And they were thinking of it in the abstract, symbolic way, with just using numbers, symbols, and providing an answer. And so what we are trying to do is to encourage them that there are multiple entry points that as students and as teachers that we need to be aware of to ensure that students have the conceptual understanding that we want them to have of the math and get excited about it. And one of the ways that we do this when we are face-to-face is by using an abundance of math manipulatives. This makes it so that we can understand and encourage our students to articulate their reasoning through concrete manipulatives and such, but also so that students can visualize not only their thinking, but their colleagues and their peers thinking and make meaning of it and add to their toolbox to eventually become a successful teacher because they see all these multiple entry points and exit points for our students to understand the math. So as we went virtually, we were finding it a bit of a struggle because we wanted to encourage our students to continue to use their concrete manipulatives, but it was sometimes difficult to see what those were and for them to explain their thinking. And so we saw a tweet on Twitter of somebody who had made some 3D printed, some pocket document cameras that were used by a 3D printer. And so we contacted Jody Donner from the Teachers College. She then activated the Ignited Lab to try and make these very, very cost efficient, effective 3D cameras that we try to get into the hands of all of our math method students. The math ed faculty has them, and they're now available to anybody who wants them. The Ignited Lab has set up a pickup schedule, so if students would like them, they can have them. Faculty can have them as well. And what it allows us to do is it creates a document camera for us to then allow students to show us their work and explain their thinking. And they can do that with their concrete manipulatives, but they can do that also with the multiple models that we know that there's more than one way to get the answer as they're making meaning of their math, and to invite them to discuss and explore this as we are in class together. So I'm going to share a quick screen of one of the ways that we did this using our pocket document cameras. As when we were just talking about CPA and what that means, you can see here on the various Google Slides, students were showing how they can see how they could make meaning of something like 18 plus 6 equals 24. How would you show that? And so in this, they were able to capture it with their pocket document camera using base 10 blocks. And here they used some counters to show it. You've got other students who then, as they were looking, they also used some base 10 blocks, but you can see how they model it different ways. And by sharing this, the students are working in groups and they can see the various way that their peers and colleagues are showing their meaning and making and understanding their meaning. It also allowed me, for instance, in one, as I was working with in a math methods course, and we want to invite our students to think, to have their teacher hat on, and how would you help a student who maybe had a wrong answer? How would you invite them to show their thinking? I'm going to show you a quick little video that I took of one student using her pocket document camera so that as the instructor, I could see how my student would help her
They
student.
would divide it in two and color in.
Hold on, I don't think I'm sharing my screen. There we go.
Just one part of that whole to show one half of the whole. And then for 1/4, they could divide their next box the opposite way. So if they did this one vertically, I would ask them to do the other one horizontally into 4 parts.
And so you're seeing as we continued to talk, she was explaining how she would help that student. And it was all just because of this little quick pocket document camera. She doesn't then have to maneuver and show me things. She can just slide it on. So I'll just show you how I slide that on right there. And then I've got my workspace set up right here on my keyboard here. And I've got an example of how I can use base 10 blocks, how I can show how I could do if I've got right here 34. If I wanted to do something, I can quickly use those base 10 blocks. So we're making the tools available for the students to be able to show their thinking and for us to know a little bit better about what our students are thinking and how we can help them a little bit more. Ignited Lab has this all set up so that all of our students should be able to have access to these, to pick these up, and it becomes theirs. It's not a borrowing or checking out. It becomes theirs that they can then use in their courses across the content areas to make their thinking a little bit more visible for us.
That's great. So what is the student response been to these cameras?
I think so helpful. I think mostly, particularly in our math ed class, they love having the manipulatives and they love being able to show their thinking and get very excited about making their meaning in another way, apart from just the abstract symbolic way. And they just get excited to see, I think even perhaps more so when they're in the classroom, because many times we encourage them to choose the manipulative from the manipulative kit that they would like to use. And so you'll see them using fraction bars, fraction circles. You'll see them making area models and maybe making a pictorial representation first, but then seeing how other students are invited to do it or how they are making meaning by using other tools. It helps them expand their understanding and get excited that, oh, wow, there really is more than one way in math. Because for many of our students, they have been brought up with this fixed mindset about getting the right answer and that being the goal of math.
All right, well, great. Thank you for your strategy today.
You bet. Thank you so much.